Good morning, everybody. I'm very happy to be here. I want to thank Carlo who invited me. And I'm a very old friend of Roland Schlich in the EGU. We worked together 35 years ago, approximately. So thank you for being here. My task is to speak to you about energy future as seen by an oil company. I'm working in Total, in charge of research and development in the group. A few words, I'm not making advertisement for our company, but it helps in understanding the presentation to see where I'm coming from. Fundamentally, I'm a scientist. I spent 20 years in the lab. I'm an ocean scientist. And then for 10 years, I managed public research in France. I've been CEO and chairman of the board of IFREMER, a marine research agency. I've also been head of the Earth and Planetary Science Department of CNRS, and also for 1 year in charge of general science management in CNRS. CNRS is a huge agency, 31,000 employees. So I'm now working in Total. Total is both a large and small company. It's large. It's 110,000 employees in 130 countries from 80 nationalities. That's largely a French and Belgian company, juridically, but actually we are working in 130 countries with affiliates in all these countries. It looks large because it's the fourth oil company in the world, private one. But in the oil business, you have to realize that 85% of the production is in the hand of national companies. Saudi Aramco, Gazprom, Petrobras, and all these companies are national companies. And most of the oil and gas production nowadays is done by these companies. And the task of the private international oil companies is to do what is difficult, what national companies cannot do. The other thing is that we are not only an oil and gas company. We are producing coal, small. It helps us understand the business. We are investing in nuclear. We are growing fast in renewable energies, mostly biomass and photovoltaics. But we are also a refining and commercialization company on gasolines and diesels, and a chemical company. We have the two biggest plants in the world on polypropylene. We also produce polyethylene, polystyrene, and also a lot of specialties in the fields of chemicals. Hutchinson is part of Total. Bostik, the number 2 in glues, is part of Total. Crivalet, number 3 in resins, is part of Total. And Atotech, which is dealing with metal finishing, number 1 in the metal finishing for electronics in the world, is part of Total. So we are also a fairly large chemical segment. And part of my presentation will be referring to the fact that we are integrated oil and gas, chemical, and renewable energy company. Now, I show this from the International Energy Agency because it is very important coming from our countries to understand that the energy cannot be thought of without thinking globally with the world scale. It's true for each business, but it's true in terms of thinking of the future. This cartoon shows GDP per inhabitant, per capita, and in ordinate, it's energy consumption per capita. Each curve corresponds to the evolution with time for a given area of the world, a given country. Each dot is a year. So what you show is that development, as measured by GDP, always goes with increase of consumption until a certain level of richness whereby energy intensity, this means the amount of energy you need to further develop, stabilizes. And then you can continue development without increasing the energy consumptions per inhabitant. This picture shows that depending on the organization of the society, you don't need the same amount of energy for the same richness. Everybody knows that in the North Americas, people spend much more energy, in particular because of the scale of the countries and the organization of the cities, as compared to Europe and other places. And that's a huge difference, depending on the social organization. The second thing is that depending on where you are in development, you are not on the same place of the curve. And this is what is the critical aspect today. Developing countries, in particular China, India, and the world, need energy to develop. And we don't have any solution so far, any technical and economic solutions whereby development can be continued in these countries without more energy consumptions per inhabitant. And think beyond these developing countries, there is 1.6 billion inhabitants who has as a source of energy only biomass for cooking and candles or kerosene lamps for light. 1.6 billion inhabitants. Meaning that we cannot think of the future without this ethical aspect of providing energy for these people. We don't have any other solution, and we have this obligation collectively. This doesn't mean that we cannot have solutions to reduce energy consumption there. We do have. We must have for the future. But at the same time, we must think of this population, and all of the negotiations internationally, like the position of China and India in Copenhagen, are based on this aspect, that they need energy for their future. The second thing is that on this curve, that's per inhabitant, and the population of the world is increasing, we know that it should be around 9 billion inhabitants by 2050. And of course, this additional population will require energy. Meaning that in any case, it's the same thing for food, for water, for energy. We need to increase energy availability for mankind by a factor of 1.5 for the same kind of well-being as today, which is not satisfactory for many people, for the future. So this is the background. And thinking of the energy as essentially the energy security of our small countries in Europe or Occidental countries is only a very tiny part of the picture. The important part of the picture is there. Now, facing this, what we are using today is fossil fuels, gas, oil, coal, essentially. People have been speaking of the peak oil for decades now. The story is that whenever you have a limited resource, a limited reservoir, then at a given time, the exploitation of the reservoirs drains the production of these particular reservoirs downwards. This is already the case in the North Sea. This is the case in many oil fields of America. And this is growing as an event in many oil fields in many countries. But at the same time, we do find new reserves. We do learn how to exploit complicated oil fields and gas fields. We know how to exploit oil in deep waters, deeper and deeper, now down to 3,000 meters of water. We know how to exploit gas in complicated climate areas. Now we do exploit gas in the Arctic, in particular ourselves, and things like that. And in the world reserves, we still have something like 40 years of probable reserves for the years to come for oil, and something like 60 years for gas. And we do find technologies to exploit complicated, unconventional oils, bituminums, shales, and resources like that, which are very abundant on Earth. We do have the capacity to exploit them technically now. The problem is not technical, the problem is economic, the problem is politics, and the problem is climate change and environmental, not the resources so far. At the same time, we in Total, of course, look at the outlooks of the international energy agencies. We do look at the outputs from each countries, but we do make our own assessments. But we do it differently. We do it from our side understanding the oil reservoirs and the investment from the oil companies worldwide. We do exploit oil in something like 500 different sedimentary reservoirs. So we do have an understanding of many different geological situations. We do have mapping of the investment and the credibility of this investment and their projection on the longer term. You have to realize that decisions on investment on oil and gas for today, the decisions of this year, will produce oil and gas by 2015 or 2017. So we do have a fairly clear outreach of what will happen in the years to come, because this is what is being decided today. And what we find is that it will be very difficult to increase oil production above this level around 100 million barrels per day. Right now, it's around 85 to 90 million barrels per day. It depends on whether you look at it before the crisis or after the crisis. And we find this because it will be very difficult that the investment will at the same time replace the decrease of existing oil reserves, 5 to 7% per year. You have to invest to replace them, and at the same time further invest to increase it. And these investments depend drastically on the price of oil, but also depends on the capacity to invest. And among the capacity to invest, there is a strong limitation, which is political. Many countries are in very difficult political situations. Iraq, Nigeria. Some are in complicated political situations. Iran, Venezuela, Russia, whereby all these situations are not in favor of further investments. The second thing is that some countries do think of their own future. One example is Qatar. Qatar is in a very stable political situation, has a lot of money, but the Qatari authorities said that they want to save their resources for their population for the long term. And they say, of course, we know that there is a demand world scale, but we have also obligations for our own country. And they are limiting, putting a ceiling on the new investments to limit the further extraction of gas in their resources. So all of these limits, political limits, good or bad, put a limit on the capacity to produce in the years to come. And our vision is that there will be a ceiling. Of course, you can think that there are other types of resources than simply oil, classical oil production, but it will take a long time to invest at a significant level for them to take a share of the national world-scale production. So we see a ceiling, meaning that despite the fact that we need an increase of resources, 1.5% per year, despite the fact that all countries invest massively, we see that around 2020, there will be a ceiling of production implying a ceiling of demand on oil in these years. Of course, you can think of the other energy resources, and we'll have to come back on this. The third element is climate change. Climate change is, in our company, in many energy companies in the world, something which we believe. Of course, we are fully aware that there is a say that some companies are paying research of climato-sceptic in order to contradict the GIEC, the IPCC reports and things like that. We know. It's not the case in Total. Our belief is that there is an expertise work. This expertise work is based on actual publication in scientific literature, and we believe in these recommendations. Actually, we are not only monitoring what is in these reports, we are getting to the scientific publications. For example, there is mediatic dominance right now on climato-sceptic views. It's 53% of the media publication on climato-sceptics. But we know very well that in the scientific literature, these are less than 1% of the scientific publications.
So we do believe in these aspects, and we do know that in order to move, we must develop energy efficiency, as been shown by Didier. We must change the energy mix, and we must complement this by carbon capture and storage. We know that we have to do that at the soonest, and we know that it's a major investment challenge, and it's better to invest now than later. But at the same time, remember, we need energy now for the populations. So we have to combine something which is very difficult. We have to provide energy now with the existing technologies, and we must invest in the future on things which are much more expensive, which are not profitable per se. Oil and gas are profitable per se, can be done by the industry. There is no renewable energy technology which is profitable per se. It also requires public funding to do it, otherwise it's not profitable. And we know that in any case we'll have to live with climate impact. And this is for the populations, but this is also for us. We monitor these aspects because we know that any one of these can have an impact on our own way of thinking of the future. Remember, if we invest in an oil platform now, it will be active still by 2050 with a higher sea level, for example, with permafrost disappearing and that kind of thing. So we have to invest by thinking decades ahead. I show this picture again, which has been produced by the International Energy Agency, simply to stress that the key to this transition is energy efficiency. And I will come back to this later, because energy efficiency is a challenge for us, a challenge for our customers, and I will discuss that. People think quite frequently that renewable energy should grow, that we must invest in it. Actually, there is massive investment in renewable energy world scale, including in our case. Of course, it is less, much less than investment in fossil fuels. Much less. But at the same time, we cannot grow that fast because the market is not there. And we cannot produce if there is no market. Let me give you an example. We are active in photovoltaics and we are investing in photovoltaics. 3 years ago, most of the solar cell productions were in Europe. Qcells was #1 in the world. We had also factories in Europe. These factories were running approximately 75% of their capacities because there was a shortage of silicon, pure silicon production, which is dependent on another segment of the industry. It comes from silicon productions for the microelectronics. And there was a shortage. So we could not produce all the solar cells we could produce. And then suddenly, during the crisis, the solar cell price declined within 1 year by a factor of 2. It's extremely rare in the industry that there is a factor of 2 change in the price of something within a year. The reason was that China decided to build massive solar cell production with the support of the governments. This was their way of launching their economy. And they did it with massive, large factories, low labor costs. So China-style production. And the market in the world, most of the market nowadays in Europe, was suddenly invaded by much cheaper solar cells. Still expensive, still leading to needing some public funding in order to buy the electricity. But nevertheless, this was coming from China. And the industry in Europe nearly collapsed. Our own industry, we had to support it using the oil money to maintain it and adjust to these new kinds of industry. So you can see that for such a fast-growing industry, it's growing by 30% per year. Being stable is extremely difficult. You have ruptures. We have limitations which come from the chain of the industry. And it depends on public policies, which will change because our public policies towards supporting photovoltaic cells will not support for a long time buying cells from China. So we don't have a visibility on the future. So it will be extremely difficult. Despite that, since we are starting from such a low share of the electricity production world scale, I'm speaking of world scale, the projection for photovoltaics tells you that it may be by 2050 something like 10% of the electricity production. Typically, 10%. It will happen if technology evolution will be maintained in order to reduce the cost, which seems feasible. But it is 10%. There is enough space. That's no space problem for contrary to biomass, for photovoltaics. You just put them on the roofs, on the parking lots, and all these things, and you can reach that kind of level world scale. So it's not a space problem. It's not an acceptance problem. It's not a competition problem. It's simply an industry growth and cost problem. And it can only address something like 10% of the electricity needs of the world population by that time. It's already a lot, but it's only this one. The second thing is that whenever you have 10% of photovoltaic production, you have to realize that it's only daylight production, not at night. So you have to change the electricity system, in particular the network, local storage of electricity, that kind of thing. All kind of investment in addition to this in order to make it feasible. And nowadays, the price of batteries to store locally electricity is similar to that of a solar cell, meaning that you double the price of electricity if you want to store it locally. So you have to invest in battery technologies, reduce the cost drastically in order to make it possible. And it will take time. So the vision we have is that, of course, we must do that for climate change, because this is a new technology, and 10% is a lot. But at the same time, beware that it is something which will last long. It's very difficult to change the energy system fast. Now, the environmental constraints we have to be facing are not only greenhouse gases. It's only one aspect. I listed here a number of other environmental constraints which we have to cope with. Water, air, or soils, not oil soils, biodiversity we have to cope with. For example, we have to reduce our water consumption in the industry drastically. In particular, whenever we extract bituminous oils, we need a lot of water, approximately as much water as oil. And we cannot do that forever. This means we must reprocess this water, recirculate it, and things like that. It needs energy. So all these environmental constraints imply increased energy consumption. Of course, we have to think of toxicity and ecotoxicity. In Europe, we have the REACH directive. There is a similar directive in North America, in Japan. And this year, China decided to establish new regulations which are very similar to the REACH directive for the toxicity and ecotoxicity of the products in the environment. There are natural resource limitations, oil and gas and others, but it's true for many natural resources. And whether you need lithium for batteries, whether you need ruthenium for new catalyzers and things like that, you have very serious aspects to consider on the natural resource limitations. But we have to live with. We have to, humankind cannot live without exploiting these natural resources. Space is an issue. Personally, I've seen development of photovoltaic fields in some natural spaces rather than forests and things like that. I find it silly. We need these resources, we need this space, and we must pay attention to reduce the space use as much as we can. And in particular, this is needed for conservation of biodiversity and agriculture. Remember, the the Food and Agriculture Organization stated that we must increase food production by 70% by 2050 for humankind to provide the food which is needed by the population and to cope with the increase of the population. So we need space for agriculture, which is not what's happening. And of course, life cycle assessment. Nowadays, we don't develop in the industry a new product without thinking of its life cycle. And life cycle means the resource, the energy and the resource limitations for its production, the impact during its usage, and the recycling at the end or its future. And again, we are doing that in our chemical company. We don't think of any new product without having a view of its life cycle, including the usage by the customers. And you have to consider all of these at the same time. And you cannot say, well, I will develop this and see later. You have to think at all these constraints simultaneously from the beginning of a new development. This is the way we are working nowadays. And as I said earlier, all of these are somewhat contradictory. For example, carbon capture and storage. In order to capture CO2 from a coal electricity plant, you need to increase the coal consumptions by 25%, simply to capture the CO2 and to store it somewhere. And this is costly. The calculation has been done in China, which is investing in coal plants massively. You may know that China is investing in a new coal plant every 10 days, a 1 gigawatt coal plant every 10 days. To give you a reference, in France we have 58 nuclear plants of 1 gigawatt. And that's it. And we are investing to replace them. China is investing each year to something similar to what we have in France, additional investment. So people have been looking, what should we do with CO2 emission in China? And calculating the impact, in particular the economic impact. The cost of electricity for China would double. Okay? So it is a very demanding investment in terms of economy. Now, when you look at the CO2 emissions, this is a way to present it, and it comes from fossil fuels, coal, oil and gas, and other sectors. So you see that fossil fuels is about 2/3, only 2/3, but also about 2/3, one way or the other. A big chunk comes from oil and gas, and the other one from coal, which is mostly used for electricity. When you look at it, you see that in the oil and gas sector, only 10% is our own consumption of oil and gas for extraction, transport, refining, and distribution of gasolines to cars and things like that. So if we want to reduce our own CO2 emission, we'll be playing there. At the same time, oil and gas energy is being used by our consumers. So if we want to reduce CO2 emission, we must play on this sector at the same time. And making a progress of something like 10% in our own consumption is approximately the same impact on global CO2 emission as making a progress of 1% there. And of course, it's much easier to make progress of 1% on consumption than making 10% progress in our own store. We are doing it. Oil and gas companies have been making progress in energy efficiency approximately of 1.5% per year. We, in total, produce the same amount of, twice the amount of oil as compared to 1990 with the same CO2 emission. Because year after year, we have been making progress, 1.5% per year. We have an economic incentive to do it, a double one. First, we don't burn this oil and gas. We have to pay for it. So we don't consume it. And the second one, we can sell it. So that's a double benefit. And now we have a third benefit, which is that we have limitations on our CO2 emissions, and we've exceeded them, we have to buy the CO2. So we have a massive interest into making this progress, and we do it. We are now investing hundreds of millions to reduce our CO2 emissions each year because it is economically profitable. But at the same time, our research is trying to provide products which facilitates the life of our customers. Denser plastics for isolations, replacing welding by glues in order to make cars and planes lighter, replacing elastomers by something which is lighter, using less resource. All of this is being done. You're probably familiar with plastic bottles for water. Have you noticed that there are much less plastic set up? Because we made progress to make same kind of strength for the water bottle with twice less mass of plastic. And this is the progress of the technology. And this kind of progress is for the customers. We're trying to sell less of our products. But there is so much demand that we don't care. We try to do it. And a large fraction of our research, approximately 20% of our research, is to do that. Now, where does carbon capture and storage play? It plays on intensive emissions. Whenever you use oil and gas for refining in our units or petrochemicals, for making electricity, a lot of the gas is used for making electricity, and coal plants for CO2. So you see that there are concentrated sources of CO2 for approximately 1/3 of the emissions, and you can imagine to capture a fraction of this CO2. It will not be possible to do it systematically. All plants will be too difficult to refit. There are many places where there is no sedimentary reservoirs to store the CO2 nearby. So we do not do it. But if we can do that on 20% of this emission, this will contribute to reduce the CO2 emission while still using profitable and cheap energy resources. More expensive, but still cheap. Another element you have to think of is industrially, you cannot work without thinking of the customer. You produce because our people want to use what you are producing. People don't need energy to have energy. You don't buy energy. You buy something to cook, you buy something to heat, to get light, to be mobile, to have workforce in the industry or at home and things like that. This is what you want. You don't want energy. And this means that when you think of energy, you must be thinking of the demand and the type of demand people want to have. And well-being, the development in developing countries, or our habit, says that whenever we demand energy, we want reliability. You want to have light whenever you switch the light, and it's much better now than 50 years ago. You want to have the car move whenever you want to be mobile, and so on. You want flexibility. You don't want to pay attention. Well, I want to use my car only in these conditions. You want to be able to use your car when you need it. And you want energy efficiency, because you don't want to spend money to do something. And energy efficiency is the key. This means that it is a segmentary industry whereby we produce and sell to a business, and the business sell to a customers. It's extremely rare that we sell directly to the customer, except one case in oil companies, which is gas stations. And you have to be aware that many oil companies don't have gas stations. Because it's not a profitable business, so people don't have gas stations. But we do in total. We have 17,000 gas stations world scale. And we sell to the direct customers. But most of the time, we don't sell gas to a customer. We sell gas to Gaz de France or that kind of companies selling it to the customer. So the organization is from business to business. And the customer is the customer of the customer. So we have to think of the whole chain and the characteristic across the whole chain of the people. And it is typical of the industry, of being sure that you understand the needs and you develop the technology to face the needs as they are expressed by the customer. And the customer for industry of the energy say, we want flexibility. That's the story of electricity. Except that they are, by having this flexibility demand, putting a lot of weight on something which we don't know how to do, which is storage of electricity. We must provide electricity when it's there. The second thing is that then you have to think of the organization of the industry. Oil and gas industry has been an industry which has developed with decades from small companies doing everything, drilling, exploration, and all of these things, to something which is massively organized in huge companies, world scale, but segmented. We don't drill ourselves. We buy the work to a drill company. We don't produce pipes ourselves. We buy pipes. Formerly, oil companies were producing their own pipes. It's not the case anymore. And we don't transport the gas except in pipes, because there are other companies doing it, except for liquid natural gas, because it's something where we do bring the liquid gas to the countries. It's a very important market for gas companies. We will be living in the future with faster evolution of technologies. For example, renewable energies, except for windmills, are still non-mature technologies, biotechnologies we are used to. In the past, refining was a very stable technology. Most refining units have been invented in the 40s, and we're still using the same kind of things. Of course, our progress are more efficient, different materials, a lot of electronics, and things like that. A lot of computers. In a typical refining units, we have something like 60,000 data points at each second, measuring what happens. So it has changed. But fundamentally, the process is the same. While for photovoltaics, the process is changing every 5 years. So we have to adjust to a new world with very fast evolution of technologies. And it's a totally different kind of research and organization. A lot of smaller companies who are buying startups because each new technology is being developed by a startup. So we are helping startups and buying them constantly. So whenever I've said that vision, both of the energy, of the changes, of the demand, of the industry, then we can face what are our research agenda. I have 6 elements of research agenda. One is that we believe that the world needs energy now. And we must provide energy with what exists. Fossil fuels. And meaning that we must be able to exploit what we call technology, unconventional oil and gases, in order to make sure that there is enough for Earth. And if there is not enough, then there would be a major economic crisis. We cannot afford not to have this now. The second thing is that we must participate in the transformation of the world energy mix, technologically and industrially. This means both making research and at the same time investing in production. And we selected to be active in the solar and biomass and the carbon capture and sequestration for research and investment. And we are also active in nuclear in terms of investment. We are not making any research in nuclear so far. The third one is that we believe that new products, we are living in a world of permanently new evolutive products with new functionalities, with more competitive aspects, with replacement of one material by the other. This will stay the same for the decades to come. So we must continue to produce innovative and market competitive products. But at the same time, I've put the words of energy efficiency for the customers, environmental impact and toxicity, life cycle, and things like that. And there are many aspects of this. you may not know, but whenever we produce a new glue now, we try to think of this glue not having a better function in the same aspect as the former one, but possibly replacing other functions. You know, 3 in 1, that's the target for any product. And we have glues now which are soundproof, which are electricity producing glues and that kind of thing. They will come to the market sooner or later. Then, of course, we don't sell crude oil or natural gas directly or biomass resources. We must transform them. And the transformation is aimed to the adaptation permanently. First, the resources are changing. New types of oils, for example, heavy oils as compared to the classical ones. This means that we have transformed our refining units or petrochemical units. New markets, dieselization of cars is massive in Europe, and we have too much gasoline production on the world now, so we must adapt our transformation process to this. It's not easy. We must work on reliability and security. That's always key in the industry. We have the obligation permanently to reduce our security accidents, and it is a very dangerous industry. So we are active on this, and technology is a matter of contribution to this. Energy efficiency of our own transformation, the environmental impact, the water impact and things like that, or the soil impact, things like that. And of course, it must be economic. Then, in order to be able to cope with economic impact, we must understand them. If we are obliged to, for example, satisfy a product with a REACH directive, ecotoxicity of a molecule in the environment, we must be able to demonstrate, that's our responsibility, not the research labs, to make sure that we understand the ecotoxicity of this product. So we do that in partnership with universities, but also with our own lab facilities and teams, which are organized across the profession. And then we are living in a world of continuously evolving technologies, and part of our business in research and development is to make sure that any new technology which has an impact on our business can be accommodated in our world. And you have to be aware that any new technology can have an impact on us. It can be biotechnologies. For example, in the last 3 years, people discovered that we can have some bacteria who are transforming sugar in diesel. Formerly, people were thinking only of transformation by fermentation of sugar in ethanol and using that in gasolines. But now we know that there are bacteria who are transforming the sugar in diesel. And we need diesel on the world. So this is an impact on biotechnologies. Nanotechnologies. Nowadays, we produce pipes which are not corrosive because they are nano-surfaced, preventing the appearance of corrosion at the surface. We are selling some polypropylene fibers which are reinforced for the industry by nanotubes of carbons. They are much more resistant. They are not in the general audience because there are rich impacts, but in the industry they are being used. High-performance computing. We need the biggest computers which exist, and we learn how to use the new architectures of the biggest computers. Information and communication technologies. We cannot live in 130 countries without exchanging every second tens of thousands of data points of information and things like that, world scale. And information technologies are used massively in our company. Analytical techniques. Since we have new types of resources, new types of products, nanoform surfaces and so on, any new analytical technique, from synchrotrons to neutron machines, to mass spectrometers, any new technology of analytics is being used in our company as fast as we can.